Okay, so now you've got a sense of what the experiment was and how we did it. Okay, so we're going to look at the theory now. So the theory behind this, if you've got a bigger resistor, you've got a bigger voltage out. Okay, and it's all based on theory that we know already. So the output voltage, V out, is the potential difference across that resistor R2. We've called it R2. So knowledge of simple series circuits can be used to calculate that V out. So to calculate the V out, we must first of all find out the current through R2 and its resistance, because V equals IR. So in a series circuit, the current is the same at all points. So the current is the voltage across R1 divided by the resistance of R1, but it's also the voltage across R2 divided by the resistance of R2. But it's also the total voltage divided by the total resistance. And you can rewrite that as the supply voltage Vs divided by the resistances added together, so R1 plus R2. Yeah. So we want to know the voltage out across R2, so we need the current times by the resistance of R2. And we've just said there that is the current. The current is Vs over the supply voltage, the total voltage, divided by the total resistance. So supply voltage divided by R1 plus R2. So what we've done is we've just transplanted I by that equation that we worked out. So V equals IR, but instead of I, we've stuck in V equals Vs over R1 plus R2 times by R2. Okay, and just to make it a little bit neater, you don't really need to do this, but this is how it's written in your equation list. We've swapped the Vs and the R2. You can do that because it's just times it. So that is our final potential divisor equation there. V out equals R2 over R1 plus R2 times by the supply voltage. Now, just to point out that R2 is always the resistance that you're measuring the voltage out across. So, for example, here, so if we've got R1 and R2, that's your V out there. Okay, but if you were measuring the V out across the top one, then that one would be R2 and that one would be R1. So it's always R2 is always the one that you're measuring the V out across. Okay. So before I move on from that and we do this next table, I want to just do an example using that equation. So I've just taken one of the questions from the question booklet, and it says for each of the voltage dividers below, calculate the voltage across the output terminals A, B. So that one first of all, and then that one. Okay, so we're going to be using that equation, V out equals R2 over R1 plus R2 times by the supply voltage. I'm aware that a lot of you could just do this in your head, but we're going to go through the steps. So for part A, V out is R2, which is the resistor next to the voltage, where we're finding the voltage out across. So in this case, it's 4, divided by, add them together, 4 plus 6, times by the supply voltage, which is 5. You put that into your calculator and you end up with 2 volts. And for part B, remember we're now looking at the voltage across here, so this must be R2. So V out equals 50 divided by 50 plus 40 times by the supply voltage, which is 9 volts. And that comes to, if you put that into your calculator, 5 volts. Okay, if you prefer to do it another way and you can do it in your head, absolutely fine. But I just wanted to do this for the sake of your notes. So I know you didn't have that in your notes, but if you could write that down maybe at the back, maybe just on a piece of paper or something like that, just so you've got the notes. It's also on the OneNote, so you can come back and have a look at the OneNote as well. Right. There's also another equation that's similar to this that you can use in potential dividers, and it's this one at the bottom here. And it never really gets enough attention because it is quite a useful equation. And it's V1 over V2 equals R1 over R2. Okay, so if you're given both the resistances and one of the voltages across one of the resistors, you can use this equation to work out the second voltage. So for example, and I've got this one here, I've just taken this from the question booklet as well, we can use V1 over V2 equals R1 over R2. The thing you need to remember with this is just the fact that V1 is attached to that one, that's R1, and that one is attached to that one. So that one, they will be the same number. So in this case, we're finding V1. So V1 over 500. Oh, sorry, not over 500. What am I talking about? V1 over V2, which is 24, equals R1. So that's that one, because it's attached to V1. So that's 500 divided by this one, which is attached to this one, which is 4 kiloohms. So just watch your units, 4,000. And that, so V1 is equal to 500 divided by 4,000 times by 24, which comes to 3 volts. So those are just two examples that I wanted to do because I don't think it's fair to get you guys just running there without any practice of this. So to practice today and for the rest of this lesson, I want you to copy down your results from the earlier page, so those ones, into this. Okay, so first one, VS is 6, R1 is 10, R2 is 1, and then I want you to, instead of copying down the results, I want you to calculate it. So for the first one, you're going to be using the equation V out equals R2 over R1 plus R2 times by VS. And R2 is always going to be this column here. So for the first one, V out is going to be 1 over 11 times by the supply voltage, which is 6. So get your calculator out. Have a go. I'm just going through it now. So R1, 1 divided by 11 times by 6 equals 0.55, which is not too bad at all. Okay, so have a go for the rest of the results that you got there, and then I'll post the answers up later.